Today we are going to work on leetcode 1203, sort items by groups respecting dependencies. I think this is a hard problem, and part of the issue is the description of this question is very complex. So we'll not go over these descriptions, but we'll use these examples to tell what's happening here. So this question gives a list of items numbered from 0 to n minus 1. For example, n is 8 here. So the items are numbered from 0, 1, 2, 3 until 7. And each item has its group, and groups are given by this array. And if an item has the group number, for example, this 3 has a group number 0, so it's in the 0th group. And also group is indexed for begin at 0. So there are two groups here, m equals 2. So it's indexed by 0 and 1. And also some items do not belong to any group. So the group for that item is minus 1. For example, minus 1 for this one, and minus 1 for item 0. And then we are given this vector of vector before items. This means this column. This means for anything inside here, this item should come before the final item, before this item. So this means item 6 should be at the position before item 1. And this means item 5 should come before item 2. And this can have several items, so that is why it is a vector. For example, here it says item 3 and item 6. They both should come before item 4. So here we have 3 and 6 as this column. And our final goal is to sort all those items to satisfy two conditions. One condition is any item in the same group should be next to each other. For example, here item 2, item 5 are in group 1. So after we sort, they should be next to each other, as you can see here. And item 3, item 4, and item 6, they are in item 0. So after sort, they also need to be next to each other. So 3, 4, and 6, as we can see here, 3, 4, and 6 are next to each other. And we also need to satisfy this constraint for this before items constraint. So this means, for example, 3 and 6 should be before item 4. 3 and 6 are here, so they are in front of 4. And for example, here item 5 should be before item 2, so item 5 should be before item 2. And this constraint can be in the same group, or it can be in different groups. So if it is in different groups, it means those two groups should be in some order, right? The group for this item is in should be before the group this item is in. And yeah, so in order to satisfy all those constraints, sometimes those constraints cannot be all satisfied. Then we just return an empty vector. It's meaning that we cannot do this sort based on the required conditions. So how to do this? What we can do is something like this. Let's draw here. So for example, suppose we have a different group of items. Let's say a different group of items. Some items are in this group, some items are in this group, and some items are in this group. So these groups should be in order, right? For example, if we record this is group 1, this is group 2, and this group 3, if inside those constraints, let's see, if inside this before items, we found that group 3 should come before group 1, then after we sort, we should have the group 3, we put it here. All the numbers in group 3 should come before number group 1, right? For example, if our group order is 3, 1, 2, then after we sort, we should put all the numbers in group 3 before all the numbers in group 1, before all the numbers in group 2. Also, within each group, for example, in this group 3, there are also 3 other items. We say they are star, triangular, and square, right? Based on the before item constraint, these items has some order to obey, right? So that we need to sort those items correctly within each group. So that is basically what we need to do. We need two sorts. One is sort the group, and the second one is to sort items within a group. The first thing is we just sort in this group, and the second thing is this: we sort everything within the group. And how to do that? So this is something called topological sort, as I can explain here. So we can use topological sort to solve this problem. So we sort twice, and the first is sort for groups, and the second one is to sort for items within each group, right? Because why we can do this is because we need all the values, all the items belong to the same group next to each other. So we just sort by group. And then second, we sort for items within each group. So how to do that? I can draw a simple illustration on the topological sort algorithm. So for example, we have something here. We build a graph like this, and they have some connections. Actually, they have some directed connections. Okay, they have some connections. So this is A, this is B, and this is node C, and this is node D. Then for each node, we actually try to remember the in degree for each node. We need to remember this called in degree for each node. For example, the in degree for node A is 0. How about for node B? Yeah, all these are directed connections. So how about for node B? It is 1, right? Because we only have from A to B. How about for node C? It's also 1, right? We only have B to C. So for C, it's also 1. Then how about D? It is 2, right? So in degree for node D is 2. Then we will have a queue. We will have a queue. And initially, we put all the items, all the nodes with degree 0 to this queue. So at beginning, the queue will only have one item. Then for each item that A can reach, we decrease its in degree. What we are doing is we just delete this connection. So for each item A can reach, it is B, then this 1 will becomes 0, right? And then for we repeat the process to put every node with a degree in degree 0 into this queue. Then the queue becomes B, right? And of course, each time we will pop up the item in front of the queue. So A will be pop up. Then we add all the nodes with a degree of 0. Then it's B. Then we update all the nodes that B can reach. So we update this one, that is delete this connection, and delete this connection as well. So C's in degree will become 0. This one will become 0. And D's in degree will become 1. Then after we pop up B and we put back all the nodes with degree 0, then we have C in this queue. And then for all we repeat this process, then we will remove this connection. And this degree will be decreased to 0. So this queue will be only have D here. Then after we pop up D, we are done. Then for each of the pop-up, then we actually have this A, B, C, D sorted. Okay, and this is topological sort. Let's see how this code will be written. So first, we need to remember how many items in each group. So for this step, to get how many items in each group, so what we can do is have a group count. How many group here? We have M group, so they all initiate to 0. And for each item, we get which group it is at. So we say G equals to group I. And there are two conditions. First, G equals -1, right? It might not belong to any group. Then we add something at the back of group count. And we also update this item. We put it to, because we already have M group from 0 to M-1, so we say this new group will be M, and then we increase them by 1. And the second condition is this G is not equal to -1. Then it's simpler. G will be increased by 1, right? So second step is to calculate the in degree for topological sort. We have some vectors to do this. Vector of G1, it is N, G2 is M. G1 means the graph connection for items, and G2 is the graph connection for groups. Okay, and for example, G1I can be equals to A, B, C, D, etc. What does this mean? This means item I connect to item A, B, C, and D. And I has a directed connection to A, B, C, D. And same thing here for group. So this means group I connects to group A, B, C, D. Okay. And then we have the D1 and D2. D1 is in degree. For example, D1I is in degree for item I. D2I is in degree for group I. Okay, then we need to calculate this in degree. In order to calculate, we use the before item require a condition. So for each one connected to, so this means for J should be before I, which means there is a connection from J to I, right? So in this, if they have this connection, J1, G1J should push back I, right? G1J should push back I because I is something inside here. And we can update D1I by 1. And then we get the group for I and J. It's just group I and B equals group J. And if they are not the same group, we do this, right? So group is G2B should push back. So this means there's a connection for B to A, right? So B push back A, and we need to update for A's in degree, D2A plus. Yeah, I think the initialization is done. Then we start to do the actual sort. We have 2 variables. Count is the total number we visited. Current is the current position for this group. We have vector position. This is records the position of each group. So this means in the POS I means in the final sorted items, the starting index of group I. Okay, so while Q, we need to have a Q here. And yeah, we need to initialize it. We need to first sort for a group, right? So it's D2. We need to put all the all the group with in degree of 0 into the Q push I. Okay, then we can do the actual sort. So we have F equals Q front. Remember to pop and count plus. And then we need to get the group of this element. This is K is so F is in group K. Then we have POSK should be equal to current, and current should be updated updated by its group, right? How many numbers in this group? Let me think. Oh, something wrong here. So actually, F is already the group, so we don't need to do it here. We just put F is group, right? So F is group. Then for each group connected to the current group, it's by G2F. So we first delete its in the we decrease it in degree. Then if D2V equals 0, we can push it into our queue. Yeah, and this while loop is done. And after that, if count does not choose the number of group, we have some contradiction order, so we just return. Okay, we are done for sorting the group. Then we need to sort for items in each group. We do this all in once. How to do that? We still need to use this queue. So queue is already empty after this while loop, so we don't need to initialize queue. We need to initialize count, and then same as here, we need to initialize this queue by putting all the degree 0 item into this queue. Then this while loop, we first copy that here and then do some modification. So now F is item, right? So for here we need to get the group for this item. And now we are doing the final sort. So we have the res as the final sorted order for the items. Then res position k should be F, okay? And these two lines should be deleted, and position k should increase, because position k is in the final sorted items the starting index of group I. So this is POSK is the starting index of group K. So we put the item F at this index. Then the starting index should be increased by 1 to put the next item in this group. Okay, then for each item, so this all becomes 1, is all 1 here, and I think we are done. So if count doesn't equal to n, we just return, then return res. Okay, let's try to run. We have some runtime error. Let's see what's happening. So G equals to group I. Oh, we forgot to write I less. Let's see, for each, oh, I forgot to write I less everywhere, right? Okay, it seems the results are correct for those two test cases. Let's try to submit. Okay, we are done. So I think this question has several difficulties for a beginner. So first you need to understand the description of this question. It's not so easy to fully understand it. Then you need to do the topological sort. You for sure need to know how to do topological sort before as a template, right? Then you need to implement this sort 2 times. And there are some requirement for the coding as well. And I think that's it. And thank you for watching and see you next time.